Hello all, welcome to Tech Capture. Myself Vishal Bulbule, and in this video we are going to see what is load balancer in GCP and how we can use a load balancer with managed instance group in GCP. So we already seen how we can create a managed instance group in GCP and what are the different features of a managed instance group. So in this video we'll start with what is a load balancer. So as name suggests, load balancer is used to balance the load between the two systems. So I'll go to my next slides. So just take example of this slide here, and just suppose you are using one of the web applications. So it might be a Facebook, your Google site, or your Netflix, any of these application you are using on the internet. So this is considered as a web tier. So there you could see one web tier in central one web tier in central B, and one in Asia East 1A. So it's a part of the same application. So what will happen if user in San Francisco will try to access this web application? So suppose user from San Francisco try to access a Facebook. So what will happen? It will hit to the load balancer of the Facebook, and Facebook or any of the application you are accessing, it will check the location of the user and it will check, okay, which is the nearest server for this user. So it will check, okay, this is US Central 1A server is the nearest to the user, and it will send you response from the nearest server. Okay, then if a user from Loa try to access the application, it will check which is the nearest, and it will see US Central 1B is the nearest server, and it will return response from the nearest server. And if user in Singapore try to access, then it will check, okay, US Central A and Central B are not a nearest, so it has to check from the Asia region or Asia zone. So it will check for Asia East one, and it will give response from the available server. So it will always try to route to the nearest server, so the speed will be maximum. So suppose what will happen if Asia is server is completely down. So will Singapore user will not be able to access the application? No, that will not happen. If Asia server is down, then user in Singapore will request this application through the browser. It will go to the healthy instance available in another nearest. So suppose Asia is down, then it will check for US Central 1B and it will return response from this server. In this case, only latency will increase and user will get a bit a less speed than the user was getting speed in Asia East one. So the load balancer is to route the traffic to the nearest server and a healthy instance. So that is how we can use a load balancer for our application. So just let me go to this my VM, and here I have created one application on my single compute engine. So I just created one sample application. If I use this in browser, it will just print a dummy message. I'll just try to print. Okay, so this is printing. This is my web application. Now what happen if my server is down? So if my server is down, and or I want to perform any activity on my server and it might take a 2 hours, so what will happen? So I'll stop this server and then I'll try to reload this. It is still working, it is still working. So it will keep working until my instance is not down. When my instance is down, this application will stop working. Okay, so it is still working because instance is not stopped yet. Once it is stopped, my application will stop working. So how to avoid this downtime in case of any maintenance or in case of any upgrade for my application? I don't want any downtime for my user. So how I can avoid that downtime also? So now it is loading and it might not give a response this time. Okay, so to avoid this time down, as we seen already in a video, last video, we can use a managed instance group in GCP. So it will be identical application will be hosted on multiple compute instances, and you can use that instance group as a single entity. But now as I am using the IP address of this application to access my application in browser, if I will have multiple instance, which IP address I will use? So suppose I have 5 VM in my managed instance group, which application or which IP my user should use to access the application? I cannot say to users, okay, these are 5 IPs and you should use all these 5 IPs. If one is not working, you can try for another. So I cannot go and say to this user. Or suppose my IP is used somewhere in configuration while deploying my application, so I cannot put a multiple IPs there. I can put only a single IP to make a connection. So in that case we can use a load balancer. Now you could see application is not working now, so in that case we will use a load balancer. Okay, so how load balancer will be used? So just take this example. What I will do, I will put one server in zone A, I will deploy application on that, and I will put one on zone B, and I will use one load balancer on that, and load balancer will have one single IP. I will may ask user, or I'll configure that load balancer IP everywhere in my application, so user can hit this load balancer IP. If zone A is down, it will serve traffic from zone B. If zone B is down, it will serve traffic from zone A. And if it is having auto scaling enabled, if zone A is down, it will automatically create one more instance in the zone. So this is having like in a region, so we will have two instances into separate zone, and this is like we are having two instances in the same zone, so we can configure both the way. So now I'll create one MIG, zonal MIG, so this second diagram, and I'll try to use one load balancer, and we'll try to see how load balancer work to access the application. So for creating MIG, as we see, we know we need a instance template. So I'll create one instance template. Okay, I'll just give the name as a web app 1. I'll keep everything as it is. I'll just change few things. I'll go in networking, and I will select a network as application VPC. In management, I want to put script for web application installation, which was printing that message. So I'll just use these two command to install Apache server. So it will install Apache server on all the instances in the instance group. So just assume this is our application we are using on managed instance group. And now I'll create a VM, create an instance template, not a VM. And now I'll go to instance group, and using this instance template I will try to create a okay, I think we missed something, so let me go back to the instance template. So we missed a subnetwork. Okay, or let me delete this also, and I'll create new one, create instance template. I'll give the name as a web app 1, or just a web app template. I'll use application VPC, and subnetwork will be subnet USC1, and in management section I'll put commands in automation tab. So during the start of the VM, it will install Apache and print this message on all the server. This is my web application. Okay, I'll just create it. Okay, and now I'll go to instance group and we'll create one managed instance group. Create managed instance group. So here I'll just give MIG web app instance template. I will use, let me reload because it's not created when we open this page. MIG is for managed instance group and I will use this web app template now. So zone, we want single zone as we want to follow this second diagram. I'll use a single zone. And I want minimum instances 2, maximum instances 3. Auto scaling, I keep everything as it is. Health check, I will select which we created in last video. And I'll create this managed instance group. So I'll pause this video for a moment because it might take a couple of minutes to create this MIG. So meanwhile I'll pause this video. Okay, so MIG is created now. So let me go to this managed instance group. Okay, and here you could see both are using the template. So let me see using the external IP if they are printing the message. Okay, this is printing, this is my web application. And let me check this also. This is also printing the message. So both are installed with the web application. Now how I can use a load balancer. So let me create one more tab and here I will go to load balancer. Create load balancer. I will use HTTP load balancer. So here from internet to my VM, so I will choose the default option. So the front end name I will give as a web app. So front end IP and port. So name I will just give web app MIG. Okay. So port 80 as we are using HTTP protocol only. So once it is done, I'll go to backend configuration. So backend will choose managed instance group. Create a backend service. Name I'll just give MIG backend. So here already it is HTTP protocol instance group. So which group? It should be MIG. Web port number it should be 80. I'm just balancing mode. I am choosing a rate. So if I put utilization, it will check for like maximum utilization. And if the traffic is going beyond utilization, it will try to route to the another server. So it just try to keep balance of the utilization. Instead, I'll try to keep on a rate. So it will check like only two request per second on per instance. I'll click on done. So I'll just disable this CDN. This is not required for now. Health check will select a health check. So this was on port 22. So still I'll use this health check, and I'll create, and now let me create a load balancer. So I'll pause video for a few minutes, as it will take couple of minutes to create a load balancer. Okay, so load balancer is created now. We'll go to load balancer and we'll check the IP address of load balancer. We'll try to hit in the URL. So make sure you are checking it after 5 minutes, because load balancer will take time to propagate the changes. So I'll try to put this IP now, and this is giving the response like this is my web application. So this response is coming from one of the instance in the managed instance group. So how will you know this is giving response from the which server? So what I will do, I will just make small changes in one of the server. So I'll just go to one of the server, and I'll try to make changes in file, so it will print message differently from one server and print different message from the another server. I'll go to compute engine here, and I'll try to log in one MIG. So from, if we are checking on MIG also, so it is printing the same message, this is my web application from both the server. So I'll just make changes in one of the servers. So instead of printing this is my web application, I will print this is my web application from server 1, and we'll see from which server it gives the response. So here I'll just make this is my web application. I'll just append server 1 and I'll enter. Okay, and let me try to see now. Yeah, now this is printing, this is my web application server 1. Now another will assume as a server 2. Now let me refresh the load balancer. Okay, this is now response from server 1. Let me reload again, let me reload again, let me reload again. Now this is response from server 2. So as we kept a request per second as a 2, if I keep reloading, it will give response from server 1, server 2, server 1, server 2. So it will make a balance between two of the system, and it won't overload only one server using the load balancer. So that is a main functionality of the load balancer. And now suppose if one of the server is down or in a, so let me do one thing. So what I will do, I'll just restart or replace a one VM. Okay, so restart one instance. Okay, and I'll restart it. Okay, so I'll keep reloading the load balancer. So it is giving response, till it is giving the response. So we'll see from which server it is giving the response. So one server is restarting, still there is no downtime in your load balancer. Your load balancer is still serving the traffic. Okay, now this 48 is restarting. Let me see if we are getting response here. So we are still getting response here, but there is no glitch when you are using the load balancer in your application. So that is the main purpose of your load balancer. Even if one of your instance go down, it will serve from another. Now you could see there is no response coming from server 1, because your server 1 is currently down and it is in restarting mode. So all the response is coming from only server 2. So only server 2 you are getting, and once server 1 is restarted, you will get response from server 1 as well. So your application won't face any downtime if you are using the load balancer, and it will try to serve from the nearest location. So this is not only for GCP. Nowadays all your YouTube, your Google, your Facebook, Netflix, everyone is using the load balancer. If you want to see the real example of that, let me show you. What I will do, I will open my PowerShell. Okay, and I'll just try to ping a google.com. Okay, so it is giving response from me this Google server, that is 183.36, and this is from my India location. Now I will try to ping Google again from the US Central One server. So this is my server we created using managed instance group, which is in US Central One. So if I use a ping from this will route me to the nearest server or another server which should be in US. So let me do google.com. Okay, so here you could see it's giving response from this IP 20102, even if you are trying to access the same URL google.com. So let me do trace route 103. So trace route not found, so let me install trace route. So we can install sudo apt get install trace route. So it will install within a minute, and now we'll check trace route. Not this, I want to check trace route for Google, how it is reaching out to Google. Okay, and same I will do on my Windows machine which is in India. So we are accessing the same website. So here you could see it is giving response somewhere from this server 173.194.198.105, which will be nearest to my US location, and the server host name you can see something iz-inf105. And if we are using from the India location, it will try to give response from somewhere near about Bombay or Delhi server, which will be in India. So we'll see that what will be the response here. Okay, and here you could see we are receiving the response from Bombay server, because the load balancer, which is somewhere backend of the google.com, is trying to route our traffic to the nearest server, that is in Bombay. So in this way load balancer will work. And if we go again back to this and try to reload, it should now give response from server 1 also, because it is in a recovered now, would be in a recovery state again. So now if we see the type of load balancer, there will be different type of load balancer. External load balancer means if you want to access from the internet and traffic is going to our VPC, which will be our external load balancer. So which is currently we created is external load balancer, that is HTTPS. Internal will be something we are using only to access within the GCP services. So if I go back to this diagram, here you could see this is the internal load balancer, because it is trying to communicate from your GCP compute engine to the another GCP compute engine or your database servers. So it is used only within a GCP services, is called as a internal load balancer. Then we have a global means when your load balancer is trying to work in different regions, so it is called global. Regional means if it is only in a particular region. So if I go back, so here you could see this external load balancer is trying to route traffic from different region. US Central 1, US Central B is one region, and Asia East 1 is another region. So this is your global load balancer, and this internal load balancer is your regional, because it is working in a single region. So that are different type of load balancer. You can read theoretical part of it mostly on a Google website or Google documentation, Google Cloud documentation. They explained it very well, what is the difference and type of the load balancer. So that's it for the load balancer and load balancer with managed instance group. If you have any doubt, please comment in the comment section. I'll try to answer your query, and thank you for watching this video.